Siddharaju, can you please start? Siddharaju? Siddharaju, we cannot hear you.
Hello, sir.
Can you please start the session? Now I can listen.
Okay.
Please start the session.
A very good morning, one and all. I Siddharajan, Assistant Professor, Department of Civil Engineering, VKIT.
Okay, switch on your video. Now you can speak.
I welcome you all to the 5th day of webinar on design and
Siddharaju, we cannot hear you.
Now it's okay, sir.
Yeah.
I welcome you all to the 5th day of webinar on design and construction of steel structure. I welcome today's speaker, Mr. Sajal Kumar Ghorai, Manager, Civil and Structural, INSDAG, for this webinar. Welcome you, sir. I welcome Mr. A.K. Samantha, General Manager, Mechanical, INSDAG. Welcome you, sir. And also I welcome Dr. C.S. Shashikumar, HOD, Department of Civil Engineering, VKIT, and all the participants for today's webinar. Now it's my pleasure to introduce about today's speaker, Mr. Sajal Kumar Ghorai. Sajal Kumar Ghorai has graduated from NIT Durgapur in 1999 and obtained MTech degree in structural engineering from the same institute. He has worked as Assistant Director in Engineering and Planning, Wing of West Bengal Housing Board, Kolkata, and engaged in their various projects. His work is related to analysis and design of RCC and steel structure. He worked as lecturer in Civil Engineering Department, Haldia Institute of Technology. Sri Ghorai has joined INSDAG in 2007 and is working as manager at, in Civil Engineering and Structural at present. He has varied industrial experience in structural design consultancy, which are various type of steel composite structures, and apart from that, he is responsible for technical promotion activities, R&D, projects and publication, etc. He is organizing national award competition for the students of architecture every year. So now I request Dr. C.S. Shashikumar to talk a few words about this session.
Thank you, Siddharaju. I think from the first four days, we have seen a lot about the construction aspects and design aspects. Now, I think it is a high time to understand how to exactly do the analysis, design, and releasing the drawings using the STAAD Pro and AutoCAD. I think today we have a highly qualified expert who is also a consultant, Mr. Sajal Kumar Ghorai. Sir, I would, on behalf of VIVEKANANDA Institute of Technology, I would wholeheartedly welcome you for this session. I think the participants will definitely be benefited out of this session, and after this session, they themselves can do the analysis and design using STAAD and release the drawings to the field. That is the important thing. I request the participants to observe what the sir is going to speak, and later on, since this is a recorded session, you can once again view. I mean, any number of times you can view the session, and you can learn what Sajal Kumar sir is going to tell in this session. I once again welcome you, sir, Sajal Kumar sir, for this session. I thank all the. I also welcome all the participants for this, and hope you will get more benefit out of this. Thank you.
Thank you, sir, for such a you give me such an opportunity, sir. Also, thanks, Mr. A.K. Samanto. I start, sir.
Yes, sir. You can, sir. I also welcome Nivedita madam. Nivedita madam is also there on behalf of VKIT. I welcome you also, madam.
Thank you, sir.
Sir, you can start, sir.
Okay.
All
Just
others,
share
please
my
go on mute.
Thank you. Good morning, everyone. I shall start, sir.
Yes, sir. Please, sir.
Just I have no PowerPoint presentation. Just I giving the brief and then give you a examples how can analysis prepare the model and analysis and design by STAAD, and then that AutoCAD drawing, that fabrication, structural and fabrication drawings, you will get. Just you've seen that how can prepare preparing drawings. There are also servicing drawings, like that electrical and other drawings. Now, at first, you have to choose the materials. If you design a structure, at first you have to what type of structure you have to design. That means materials. At first, you choose concrete building or bridge. Concrete means RCC, basically RCC building or RCC bridge. And there is steel bridge or building, industrial sheet, and steel bridge also. And you have to mention that materials also strength. That means normal steel with up to you have 350 MPa when you design. Basically, we have E250 MPa. We have to design that steel building basically up to maximum 350. But special steel, you have to design that stainless steel, high strength steel. That above of 350, they 450, and that India in 450 maximum. You have to design that materials and cold form steel also. And also another is the steel composite building and base. By STAAD, when you prepare a model, first you have to collect the architectural drawing before any project. Any project if we initiate that first you record the structural and not structural architectural drawings. Architects actually dominate that project. They have first services and other all details is there in architectural drawing. Then you have to prepare by STAAD for a column or beam layout plan as per the architectural drawing. You have to record for that prepare the models. And when preparing the models, you know that the joint coordinated by STAAD V connector. Previous model is the model STAAD is the very STAAD and STAAD V STAAD for V8I. Then their name is that STAAD for connect software. You prepare the model that at first, as per your architectural drawing, you have to fix that where the column and beam, that what type of beam is there, is cantilever, safety supported or not safety supported, the secondary beam or primary beam. That you have to prepare the model by joint coordinates, member indices. Also, the slab portions you have to element indices. They take that slab by element, and that support conditions that as per your support fixed or pin, and member specifications. Member specifications is when you moment the release, start end and bottom end. The industrial set, purlins or secondary beams, you have to release the moment. Because of that, that joint or the clear joint or anything else. So not take movement that sections. And then you have to properties define that model. You have to define the model. Basically, two type of properties we have given, that substructure and superstructure. Substructure of the steel building, basically we are the follow the RCC. That means foundations, below the ground level, that substructure, that means foundations and the pedestal or below ground level column and pin level beam, that must be RCC. And not must be, you generally prefer the RCC because of the corrosion of the steel section. So you generally prefer the substructure of the RCCs, and then superstructure to provide the steel sections. Then define the load, earthquake load, then wind load. Earthquake code is there as per madam also details elaborately defined that earthquake seismic load demonstrations. 1890 part 1 2016 for general provision for buildings, 193 part 2 for liquid retaining tank elevation the ground supported, and part 3 for beach and retaining wall, part 4 industrial structure and stack like structure. Instead, that only they are in part 1 and part 4 for you to design that stat model. And wind load, as per IS 875, you have to define 2015. Then you have to assign the loads, dead loads as per IS 875 part 1, and live load as per IS 875 part 2. Wind load also given that, and earthquake or seismic load for part 1 for general building. And also, if you the hilly areas, that structure is situated in hilly areas, snow load also one of the major criteria there for that structure design as per the, you have give the load, assign the load as per IS 875 part 4. Then you have to load combinations as per strength criteria and service criteria. Service means deflection criteria. Both criteria is there for the, then you have to perform analysis and print the member forces. For that member forces, you have to design the member either STAAD, either in manually. Generally, we are follow that all analysis done by STAAD and member designed by actually manually. Designed by manually means then you have to print the support directions, that foundations, all foundations designed by that support directions results. And we generally follow the code for designing IS 456 code practice for the print and removal that RCC structures. And then for IS, basically substructure you have designed by that code IS 456 2000, and superstructure that IS 800 2007 general construction of steel that design the members, beam, column, etc. And as per architectural drawing, that plane layout for day load, what load we assign that members, that outer wall thickness depend on the thickness. If you follow generally outer wall 200 mm brick wall and inner wall 125 wall, other glass panel, that depends on that load you have to that provide that models. And also full load that depend on concrete cell, concrete slab, and also parapet. And sorry, assign that dead load, not dead load. This is the live load, calculation of the live load, room, corridor, kitchen, staircase, access provide, flat roof. That actually that code is there. IS live load IS 875 part 2 that defined the 3 kilonewton per meters in corridor that and kitchen and staircase area. Other areas are defined that that code is clearly says that what load you have to give in your models, and then you have to calculate the wind load as per IS 75 part 3 2015. This code, if you assume that the building, and suppose you assume that G plus 3 story building, 4 story building, and that building area 12 meter by suppose 8 meter, and building height means if each story height is 3, then 4 to 4 height is 3 meter, then is around 14 meters means 1 meter from ground level to pitch level, and other 12 meter plus 1 meter is parapet, to 14 meter heights. Then depends mainly you have when structure analysis. At first you require the where it is you have to design where it is, location of the building means where it is structure is you have to construct it. That required for that in Indian conditions, the wind load and earthquake both, the seismic map is there, and for earthquake and wind for wind map is there. For depends on that location, you have to calculate the basic wind speed that map figure 1 in code, that actually wind load map, and also Annex A. Annex A, if you see the that Annex A is page number 51 in that code IS 875 part 3 in wind load code, and figure 1 you see that page number 6 that wind load code, and from that you have to basic wind speed calculate from that. For Kolkata, it's 50 meter per second. For as per clause number 7.3.1, that page number 10 in that code is F. F means on the wall of the structure static wind load given by that F, CPE minus CPI into A into PD. That means CP is the internal pressure and CPE is the external pressure, and CPI is the internal pressure. Area A is the area and PD is the design pressure. CPI for that code you have to that CPI depends on the opening of the wall. That clause 7.3.2.2, if opening is less than 5%, this come plus minus 0.2, and for 0.5% to 20%, that's come plus minus 0.5, and above 20% opening, that means door, windows is there and some opening is there. That depends on the way opening percentage. If you calculate that CPI, that briefly there in clause 7.3.2. This is also page 11, I think. And next, you have to calculate the CPI for the wall. Actually, longer dimension building is L is assumed that 18 meter, and shorter dimension you have to assume that 12 meters. So height is there. Height also, height of the buildings is equal to 14 meter. You assumes that for G plus 3. H by W calculate, and also L by W you have to calculate. That depends on that table 5. Clause 7.3.1, wind load, wind angle 0 degree. That means along the X, if the wind is coming, then CP is from that code 0.7, and leeward side and other side, that opposite side, the windward side and that opposite side of the wall, outer side, that CP is minus 0.2. Minus means away from the building, and positive means on the building. Load is acting on the building, and away from the building load is And other surface, other two surface is minus 0.6. Similarly, wind is coming in 90 degree, then means other directions. That windward side force is coming CP 0.7 and 0.25. That's and another design wind speed VJ, that VB equal to K1, K2, K3, and K4 as per clause 7.3. Previous code K4 is not there, but now is there included that after divisions they include that K4. K4 is many cycling. Actually, K4 is that cycling coefficient. K1, everybody note for the probable life of the structure depends on that table 1. K1, you assume air is 1. K2, generally K2 from the table 2 as per clause 7.3. That depends on the roof elevations. Then 14 meter, here's a 15, I think. And that depends on the category also. Category 1, 2, 3, and 4. That category, we have provided the category 2 open terrain with scatter obstruction 1.5 meter to 10 meter. That depends on as category page 5 to 8. That wind load code is there. That depends on the category and height of the roof that K2 is coming 1.05 and topography factor K2. This there the clause as per the 6.3.3 annex C is up to, we assume that flat land up to 3 degree is slope of the land where they constructed your building, that is up to 3 degree that is coming on, and annex C is the formula is there. You have to calculate from that. Up to 17 degrees and above 70 degrees slope, that's come is 3.6. 0.36, not 3.6. And this code, another factor, I say, the cyclonic region for that means sea coast area, you calculate the K4 as per clause 6.3.4. Then you have to calculate VZ and also wind speed PZ equal to 0.6 VZ square as per previous code. Now another inclusion that the design wind spacer PD equal to KD, KA, KC into PZ. Previously is not there in previous wind code. KD is wind direction factors as per clause 7.2.1. Average area average factor KA table 4 clause 7.2.2 and combined factor KC 0.9 as per clause 7.3.1.13. That PD is coming 1.3 kN per meter square, and that PD you have to, that for wind load on the wall of the building, when you give the load, that CPI and CPI, if you, that CPE plus CPI is coming 1.2 for windward side, leeward side, CPE plus CPI is 0.2, plus value is coming that on, and minus value is coming that on. When you putting that STAAD, W wind load X positive for internal coefficient positive value that coming and negative value that coming, and other side that Z directions, that means 90 degree loads. If the other directions is wind is coming, then 1 point, that load is the 1.2.0.1, that is the Z plus, wind load Z plus and wind load Z minus. Next, calculation of the earthquake load as per IS 1893 part 1 2016. The design base here you computed by STAAD, V equal to AH into W, horizontal design horizontal seismic coefficient, and W is the seismic weight of the structure, where A is horizontal coefficient seismic coefficient is equal to Z by 2 into I by R into AC by G. Z is the zone factor and I the impulse factors, and R is the response factors, AC by G average response coefficients. That J zone factor equal to 0.1.6 for zone 3. The seismic zone map of India that depends on that zone, and is there NXE, and from table 3 you get that value 0.16 for Kolkata, 0.16. Response reduction factor RF 3 for RCC and steel building, ordinary moment resisting frame from table 3, and other also therefore sorry, 5 for the RCC building, reinforced concrete building, and steel building for special moment resisting frame. And also importance factors as per table 8, 1.5 for important structures, school building and others important structure 1.5, and residential and commercial building for 1.2, and all other building 1.0. Also, STAAD, you have to put that type of the soils. For table 4, they are in that code. For hard soil, take 1, medium soil 2, and soft soil 3. And type of the structures, RCC building, part 1 or other is industrial category 1 structure, part 4 for 1, steel frame building 2, and all other building 3, stack like structure part 4, 5, and damping ratio in 0.5 in structure. And depth of the foundation, you have to put in that depends on the your structure, what is the depth you provide that 1.2 meter or 1.5 meter, that's you give that. And another thing, you have to give the load combination as per IS 800 table 4, that strength criteria, you have to analyze the strength of the different member of the building. You have to that as per code, you have to the 1.5 dead load, live load, wind load also there. And when dead, live, or seismic or wind, 1.2. And as per clause 12.2 of IS 800 2007 for earthquake, that seismic load, you have to provide for connections design that combination is coming 0.9 plus minus 1.5 seismic load, and that also 0.9 dead load plus wind load, and 1.2 dead load plus 0.5 LL live load plus minus 2.5 seismic loads. And loading conditions for the service for deflection criteria, you have to that load combination, dead load plus live load, all are 1. For 2 load, we putting the 2 load, dead load, seismic or dead wind, that 1 plus minus, and dead live or seismic or dead plus live plus wind, that's. Now we start a STAAD in model. You go to the new, when start for connect, and new, yes, and open that start for connect, and that structure you have to suppose is structure on any name, you have to provide that your file name. Suppose the building 1 or anything else, building. And then analytical models, and also user units. You have to English that pound foot, and you go to the metric, and that create. Then that's PA connector, that's the menu bar and toolbar also there. As per menu bar and toolbar, you have to prepare the model as per your architectural drawing. You assume that 18 meter by 12 meter is building, G+3 buildings, and 18 meter divided by actually 6 meter, 6 meter, 6 meter, column in between the 6 meter, and along the x direction, and along the z instead to see x direction along the directions, and this is the vertical direction y direction, and other direction in Cartesian coordinate 3-dimension Cartesian coordinate, and other in plane other direction is the z directions. This x directions, z directions, and this is the y directions. And 12 meter you divide by 4 meter, 4 meter, and 4 meters. If the geometry, view, select, specification, loading, analysis, design, and utilities, that menu bar and toolbar also in individual menu bars, you give that toolbars. By this, you have to prepare the models first. At first, you have to take along the direction 6 meter. This is the, if you see comment file, this is the main comment file. In utilities, there in the comment file, date, unit, and joint coordinate. Also, that joint coordinates, member incidents, and others, all you have to type, and then also you have to whole model prepare. Otherwise, menu bar and toolbar, you have to follow the prepare the models for that. And next coordinate is the 6 meter, next is 12 meter, next 18 meter, this is also beam number 2, 2 to 3, 2 coordinate, this is the 3, and 3 is the 3 to 4. This is the 18 meter. Another in geometry, there is the transition repeat. That is the good tools. You have to take less times. You have to prepare the models. Select this. Actually, we have just draw the plan. 18 meter by 12 meter. That gives. Repeat. That plan means x direction and z direction, z directions, and then 12 meters length along the z direction. That means 4 meter individually. We have to 3 repeats, and you have covered the link steps. If you go to the view and top view, this is your plans. That 18 meters, 6, 6, 6, and 4, 4, 4. Assume that a building is 18 meter by 12 meter and height is 40. And then also again go to the geometry, and that at first select and y directions. This is the ground level beam, and below we have go to the 1.2 meters. 1.2 plus pin level is on. If pin level beam is there, then suppose 2 meters 1 meter pin level to ground level and 1 meter below the ground level. So 2 meter, you assume that 2 meter, that minus, because of that below the ground level is 0 level, pin level is 0 level, below to the minus 2 meters. So link, that is, go to the view and 3D model. This is sorry back. Beam is coming for link. Okay. Then again to go wrongly placed. So just you have to go view value, select that set for the only for that node cursor, because only not beam foundation below that not beam is there. So only you have to select the link and go to the geometry and repeat. Okay. Yes. Go to the geometry and same repeat and y direction 3 meter of each. Length on. This is the ground level view. You see the 3D view. You see the ground level view. This is called 3D view, front view, top view. All that isometric into single views. Then select the top. So the select only select object, because of that we have covered the secondary beam. When design the slab, the 6 meter by 4 meters is difficult. The slab thickness is coming too much, so the secondary provide the secondary beam. Okay. Select the that 6 meter, all 6 meter beam. Then geometry, you to node insert the node at midpoint. Insert the node. Then insert the node at midpoint. Then beam cursor, geometry, add beam. Then display the whole structure. Click here. This is the first floor. This is ground floor, and this is the first floor shell. And then upper floor also you. This is the main beams of the structure. Then they repeat geometry, go to that, repeat, and other y directions, and 3 meter, 3 link step. Okay. When you see only your main structure is coming with secondary beam, you have, then you have to put the secondary beam. Go to the view. With the secondary beam, you have to then repeat geometry, repeat y direction, 3 meter spacing, and 3 floor. That you have not to link step. That if you give the link step, then from first floor you have to, and this point is column is coming. So avoid that link step for secondary beam. Go to the view. This is the whole structure. Your model is prepared. Then you support conditions. We assign the support conditions. That selected is the supports. Oh, at first you have to select the node. That node cursor. Hello. I think back their geometry going to the back. Actually, wrongly back is there. That's so coming is back first. Just by putting the another. If you go into the back, then all are deleted, I think. Now is the my support giving the supports. Define the supports. Define the supports. I've not seen that select support only fixed and assign that fixed or hinge anything pin or any foundations. You have to provide add on that and then selected that pin and assign. And after that support conditions, that secondary beam, you have to release the moment. All secondary beam. At first select. This is the loading and specifications. And release the moment. Actually, we work with the previous STAAD for VIVEKANANDA. Now the STAAD connect is the view select specifications where the member releases. I think common file specifications. Okay, I'm also typing that member releases. Member release. Member releases. Member releases. Then you have to member number. suppose that 284 lakh. 84. Start. MX and member related MX, MY and MZ. Similarly, see the secondary form. Int MX, MY and MZ.
Sir, we are unable to see it. This thing. I think you need to share that screen also.
Sir,
I think you are working in another screen now for the
no,
release.
same skin, sir.
Same screen. So we were unable to see what you did actually.
Actually, stat file, whole skin is their stat file. Along that file, geometry and other thing, and this one, and not seen. Sir, same. Stop sharing, and then.
No, sir. You released no. Just now you released the moments right in the beam.
Yeah.
Yeah, we did not see what you did actually. There.
Okay. Actually,
Specifications. I think we should go to specifications.
Actually, actually, that maneuver is not seen now. Actually, we work with the stateful VIA and for secondary beam. So that's actually.
Yes, sir. Yes, sir.
But I think they are in geometry or they are memory.
In VIT it was there in spec.
Previously, that stateful VIA is very extreme with us actually.
Yes, sir. Yes, sir.
This is the and now it's not that one. I'm not seen now. So just I have to just okay, sir. Now in difficulties is there. We have to numbering that beam, secondary beam, then that study editor I put it, sir. This is the 284 last beam, and then we go then secondary beam. That's one. Okay. 15, 14, 30. That means go to the utility and start comment file to 13 to 13 to 54 to 13 to 284. Okay, you see all my secondary beam views.
I think you can do that in the above. You have specifications there.
Okay.
Just above the whole structure.
Also, obviously, sir.
Yeah, here right towards
Uh,
right you have specifications.
Actually, okay, sir.
Not in the utilities, sir.
Okay, okay, sir.
You go to specifications. Their specifications is there, no?
Okay, sir.
Above the model, just above the
Okay,
model.
okay, sir. Then define the loads. First one load. That what the structure is coming, what type of loads is there, suppose 1.34. Actually, we have to put on that in code there 10 meter and 10, 5, 15, 20 meters, that is that height also there, but we are saying that 1.34 up to meter height. Intensity exposure if factor is not given, then take on. Then seismic as per Indian codes, ISO 15206, the putting value as per your zone factor and other things. Also generate also, that means Kolkata. Automatically coming 0.16, and that still ordinary frame buildings. Importance factor, if you take other building or residential building, that take coming from that 1.2. And suppose it's the medium soil, and this is the steel movement resisting frame, ordinary or special, that movement resisting frame, and damping it 5%. And foundation depth, actually below ground level is coming 1 meter, so generate. And then you have to put the seismic weights. That means that you have to provide that member weight and other things. That uniform. Suppose that big work is a 200 mm big work and 3 meter heights. Unit load is 20 per kilometer cube. That means coming 3 for 12 meters. 12. This is the give the positive value because of the flow weight, seismic weight. And then the secondary inner wall is coming 125 is suppose assume that 125 big works, so 125 into 20 into 3, that is coming 7.5. And parapet wall also 1 meter, that means coming 2.5, 1.2.5 into 2.5 kilonewton per meters. That and another member weight, that floor weight, that means dead roll of the slab. Suppose assume that 125 mm slab thickness, so it's coming 25 kilonewton per meter cube, the confidence You need weight. So coming 3 point something 3.1 to 5, 3.1 to 5. Range we have to that below first floor, that means ground level slab, we have to provide that not slab, RCC slab. So this is avoid, mass is not participated. So it's coming 2.52, take height 12 meter, that means 12.5, and 0 to X range is 18, Y range is 12. Go to the view value. You see the top 4 beam is coming outer wall. The top floor is only coming the outside parapet wall loads. Floor weight. The outer wall. You go that study return. You assign the wind and that earthquake load, member weight and floor weights. Then go to the primary load cases. Primary load cases. Number 1. At first we have to provide the earthquake seismic loads. Load X, load Z, then dead load, light load, you see the wind. Load X, plus minus also only one load we have to provide now. Wind. Load Z. seismic load. If you do that static analysis, though that seismic load, and dynamic analysis, they go through the response spectrum method. Just to that code IS on 3 RSS acceleration X. That putting Z value. This value is equal to acceleration Z by 2 into I by R. Z is 0.16 by 2 into I is 1.2 and R is the 3 for ordinary steel and moving steel frame. So it's coming around 0.36. 0.36. The scale is 1. Also soil, medium soil is selected. Then add. Also in the cell point, sign is all have to add positive, Y and also Z. And that load is giving to a sign of that. And memoid and also giving to that, and go to the STAAD editor file that
Hello, sir.
hello.
Sir, if you are going to this STAAD editor, once again you should share that screen also, sir. Otherwise, it will not be visible for us.
STAAD editor not is coming.
It is not coming. You have to share that screen also. You should stop sharing this and share that screen, sir.
Okay, I don't know. Oh, that time also not coming, huh?
Yeah, that was the problem.
Oh. Okay.
Meeting screen first.
It open.
Now we open the editor file. Now we
It open file.
Again you go to the meeting screen.
Meaningful হবে না, no dot. এটা বলে দিই। Sir, one thing is that when hello.
Yes, sir.
Sir, actually, one thing is that when you open that STAAD editor file, then STAAD editor file when minimize, then we open that meeting room, enter the meeting room. Otherwise, not enter the meeting room. When open that STAAD editor file, I am not enter the meeting room. open the meeting room file. Meeting, that means that meeting room.
Okay, sir. Okay.
This is the problem is coming. Actually, that easily we use that one load is putting that dead load, that copy to the by statutor file, that earthquake load is the, that putting actually.
Yes. Yes, sir. Yes, sir.
So otherwise, you're going to that edit every time add this uh, member weight,
Correct.
member load,
That will
and
be
this
useful.
takes time. Otherwise, all directions is GX and also same is GY and GZ. If you put on load, then copy it, I think. That's the data. And then throw it. Hold. 2.5, 12.5, 0 to 80, 0 to 50. And another load here is the for load, is for live load. You have to give in that part of the live load. For actually code is 800. Calculation of the seismic weight for the live load is as per table 10 of ICD earthquake load, that is 18090, that tell that from table 10 live load, if 3 kilometer per meter square up to that 25% load you have to take in that seismic weight. And above 3 kilometer, if load is 3 kilometer per meter square and above, then you take the 50% of the. So that live load is 3 or 25% coming, 25% of 3 kilometer meter square. That means 0.75. That load also coming. This you have to assign as per the members. Two point five. 2.5 from, that means top. And move floor. The outer beam, top 4 outer beam. That 12. and 7.5. In STAAD editor, I have that Y and Z direction that load is given in STAAD editors. Select new structure. Then date load, 14-bit member load. This is get from minus because downwards or earthquake, they are all giving that positive sense load when putting. Left. 2.5 to 12.5, also 0 to 18, 2 to 12. Live load, only 4 load, 80 Newton per meter square. Eighteen 0 to 12 is that. The assign is assigning that rapid all outer that's selected and assigns 12.5. With this flow 12.5 layouter essence and inner that outer periphery is 12 km per meter square dead load and internal all, and this is the parapet. Then assign the wind load. Wind load at x directions. That factor is coming 1.2 1.2 that windward sides, and range is 0 to 13. This is the -1 because of the below there, and range x range is 0 to 0.1, 0 to 0 to 12. At yeah, coming. And point x direction factor is 0.25. That leeward side, other sides 0.25. It's coming 13 meters. This is x range is 18 meter. That means 18, 17.5 to 18, and 0 to 12. And this is the at. This one. And other surface that means side faces that -1 to then 0 to 18. Z range is 0 to 0.1. That one. into 11.5 to 12. Sorry, factor is coming. This is 0.1. Previous factor also 0.1. 0 point other surface 0.1. Modify it. If you see that value is positive, that coefficient CP minus CPI, that if positive, then load is coming on the structure, and if negative, that away from the structure. That is that sign. If you not change, then that factor you are putting that plus or minus. Similarly, you have to put in that Z. Will load Z other directions also. Then we go to the next the load combinations. That first load, dead load into factor is 1.5 for step, and dead load plus live load.
Sir, why don't we give generate load command for combination? We have time
Ah.
constraint.
That load combinations.
Yes, sir. Generate load command we can give. No?
That not putting that stat, we have just give you that load. What type of putting that load, that just say.
Okay.
Actually takes more time.
Yeah, to give all the combination.
Okay, I will. My another file is there. I will that. Okay, sir. Just hello. Stop sharing is
Sir?
off now. Stops. My screen is visible.
No, sir, it is not visible.
Oh, okay, just. Actually, my stat file is closed. Just open and then I'll share it. Not much more time. Sir, now is coming?
No, sir.
Not coming, no?
No, not yet.
Same problem. STAAD editor file I open and then okay.
Yeah, now it is visible.
That I write in STAAD editor file that load combinations and just
Sir, why don't you use this generate combination command?
generate load combinations.
Yeah.
Okay. Generate, no?
Sir, otherwise, shall we use few combinations only and then continue with the design?
Okay, sir. Okay, sir.
Okay.
Okay, sir. Then I'm opening the another file, sir.
Yes, sir.
Then, sir, with that, any another file opening, then give you that brief, sir. And this is also one another file. If you see that, I'll just delete that. That load combination, you have to dead load plus for 1.5 and 1.5, and 3 load cases, dead load, live load, seismic or wind, 1.2, 1.2 and 1.2. And for that seismic conditions, for that load conditions, as per seismic code, that required this 0.9 dead load plus 2.5 seismic load or 2.5 seismic load. And another load is there, a dead load 1.2, live load 0.5 and plus 2.5 seismic load. That load combination, serviceability, dead load per live load 1, and when the other code is there, dead load plus live load plus seismic load, you have to putting that all combination 1. And then you go to the perform analysis. Just my another friend, I delete that perform another thing, that load combinations. You see that load combinations.
Sir, are you using new file?
This is the new file.
Sir, I
This,
think you have to share that file, sir. We are able to see the word one only.
that is share set.
Okay.
See, said that file.
No, sir, can you just scroll, maximize the
As I stop
structure?
and then opening.
Yeah.
This start file is coming. Skill set
No, sir. No, sir.
not coming. Coming set.
Yes, sir. Now it is seen. New file.
New file.
Yeah.
This is the load combination. Putting that seismic load, dead seismic X, jet, dead, live, and wind, and that load combination. All load combination is there. See the right sides. If you open is that 1.5 into 1.5. This 1.2 into 1.2 dead load, live load, and load, that type of there. And then this is from coming from the that serviceability, dead load plus live load. This is the combination on one factors. And then we have to perform analysis. Analysis comment, the perform analysis, and then load data. Sorry, that not analysis only. Oh, we have to post analysis and defined the load data. Suppose for this is the and this load data when the member forces, member section force and member force at member force, section force and others. Assign member forces, then load list for deflections serviceability criteria at this, and then you have to print support reactions and joint displacement, support reactions and displacement. Offset, view, just and then the support reaction only assign the support reactions. And then go to the post analysis. Go to the steel for steel design. As far as you select that current code, that IS 800 limited method, that select the parameter, we basically Fy and K and yield strength, that one K, Kz, and give the other value, otherwise they take track. Okay, then define the parameters, yield strength 25, already 25, 250, if we get 250, 250, then put in 250 at X is take for the K value is 1 coming for the hinge, that IC 800, the support condition depend on that. If both end fixed is 0.65, but fixed, but totally fixity is not coming that, so we follow that. Generally we take that beam building, beam and column 0.8 basically, and for beam 0.8 or 8.85 K value. Same is AY KZ and track. If you take elaborate result, track 2, and medium level, intermediate, just a few details, then track 1. Just assign. Above name are not substructure, substructure is the concrete. Then come and check the code and take off. If you take the member, take off. That's all, and you have to analysis. Run the analysis. Oh, sorry. Actually, still take up and check code is not assigned. Still check code. Assign, still take up also. Then you have to run analysis. You see that this is the result. Deflection. Also, you have to creative view, and suppose you have to direction, select one any floor level, just that load case, load combinations, see for dead load plus live load. And you, when you that view values, give that from post-processing mode, yes, and that annotate beam result maximum, what the beam maximum moments in maximum moment. Otherwise, annotate is all that in beam result. See that beam result share and in axials also. And
Sir,
maximum.
can you throw some light on the design and we will end it up, sir, because we are falling short of time for next session.
Yes, sir. Sir,
Yeah.
I am just see the drawings and other files.
Yeah. Sir, we will do one thing, sir. Drawings, can you send it to me so that I can share it to the participants? Because
Oh,
there is a lot of time constraint.
oh, okay, sir. Actually, it takes more time, sir. Model and loading file.
Yeah, correct, sir. I understand, sir.
Okay, sir. And just okay, close. In general, on file, sir,
Ah,
uh,
sir.
one I'm file just open for that industrial structure. Just 2 3 minutes. They give that this is the on type of building, and then
Okay.
just to give you that outline. Say what is there, what
Okay,
is.
sir. Okay, sir.
This is the one type of industrial warehouse. Warehouse. We see that frame, that basing system. You have to provide that middle. In building also, if you provide the basic system, the middle of the structure, because of that, actually, if you provide the side, then the temperature varying and stress is coming from the side member. So if you also for building, if you provide that the lift portion in core, nearby core, but that depend on architecture, the dominating maximum. If 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 code giving that code shear wall or that leaf or other thing is there in building, then is you could actually minimize the member sections. Similarly, you provide the basic in the middle. If not provide, that's okay, but when you design that provide the middle, that's actually fine. That's okay, sir. Other
Sir,
various, sir.
sir, can you mail me one building project and one warehouse and drawing substructural drawings of the same?
Oh, okay. Okay.
We will
And,
give it to the
I mean,
our participants so that
uh, uh,
they will get benefited out of it.
obviously, sir.
Yes, sir.
Obviously, sir. Just one, I'm open on just drawing also, just on drawings, sir.
Yeah.
On 2
Yes, sir.
minutes.
Yes.
It takes time. Open the drawings.
Yes, sir. Yes, sir.
Just on fabrication drawings, sir. This year,
Okay, sir.
yes. Our building actually G+3, B plus G+3 story building, our office buildings here. One, sir, can you see, sir?
We can, sir. We can.
This is the only column, steel column. Actually, yes, all a star column, and that connection drawing. Other drawing is there, but plan I see on plan drawings. Open them, okay, na? See, sir, I send you, sir. Okay. This
Yes,
is
sir.
the
Sir,
fabrication
please.
drawings on the steel
Yeah.
and beam connections, plate connections, secondary connections, or this is the base plate and others junction
Okay,
book.
sir.
This is the actually base plate with that. Okay, sir. Thank you.
Yes, sir. Sir, please mail me one building STAAD
And
file and drawing, and
or
one warehouse STAAD file of one warehouse and its drawing, sir.
okay, okay, sir. Okay, okay.
I think we have come to the end of this session.
Yes, sir. Actually,
Really, sir, it was a long session, and you have really spent a lot of time for teaching us the STAAD Pro, how to design the steel structures using STAAD Pro. Sir, we will not take up exclusive question and answer session for this session, because it is already, we are running short of time. Only, sir, I have only one question.
sir.
That is, we did model for footing foundation part, it is concrete, and the above part is steel.
Yes, sir.
Can we still model it as the moment resisting connection between those two, or do we have to give any to release the moments at the junction
No,
between
no,
steel
no.
column and RCC? Yeah.
No, no, sir, not release that junction point. We take movement, and that type of, we have designed that base plate and other actually
Uh-huh. So it will be moment connection itself.
box type.
Base plate
Box
will
type.
be.
We have designed that not release the movement star column with that foundation box type and that bolting box type
Okay. Okay, sir.
with that base plate with box type and with that
Okay,
box
sir.
type connection with that pedestal with that steel column.
Mhm. Fine, sir. Fine, sir. I think, sir, you have really given us
If release,
more information. Yes, sir.
you can done in Stratford that that food in the RAM software putting that and Stat also putting another that in that load combinations maximum that axial force that the endpoint if is joint pin joint, then that putting that another file is required for your design, sir.
Okay.
If
Okay, sir.
release that it gives the basing not basing give the basing system, then is main problem is coming that.
Okay.
And
So if we go for
if you
bracings,
both direction is movement connection, then star column for star column you have designed, then it based must be fixed, sir.
so how to design this star column in STAAD? Do we have any option for this?
Obviously, sir, I did that file also send you, sir. That start right.
Okay.
Actually, we take the equivalent. That means on I section and on I section card. That card sections just IX and IY both direction is same coming in that.
Okay, sir.
X I start means I 600 cutting
Okay.
ICMB 600 cutting that both direction I 600 that means is IX and IY plus IX plus I. That means just add that IX plus I, then star column IX and IY also same coming the both directions that in
Okay, sir.
actually you have to put that area and movement IX, IY, IJ. Assign that.
So we should separately define. Okay,
uh,
sir. As a general section,
different
not regular
section,
section. We should
not
define it as
regular
a general
section,
section.
general section.
Okay. Okay, sir. Okay, sir. Sir, I think I have understood about that also. I think really you have taken a lot of pain in
Lot.
explaining the entire thing for us. Though since we have a lot of time constraint, we have another session also by Ghosh sir.
Yes, sir. Yes.
I think because of that we have to stop here. And on
Obviously.
on behalf of Vivekananda
Actually,
Institute
sorry
of
for that.
Technology,
Actually, main thing is that I am very much accustomed with STAT V8, but STAT
yes, sir. Yes, sir.
Connect
Yes.
2 days
Connect is
before. Actually, new version is STAT Connect.
yes,
We
sir.
have, actually,
Yes,
I'm
sir.
model by STAT V8. Then for designing, that's another
Yeah, I
computer.
understand.
But design not is by STAT. Actually, we are doing the manual design.
Okay, okay,
All
okay.
analysis by the software, but all on manual design. And that student life, when I joined the housing board, that time also doing that manually in analysis. that movement distribution condition method, that type
Okay,
of
sir.
distribution we're doing that. But nowadays
Okay.
software analysis doing by very short times that, but design we're doing that Excel sheets.
Okay, sir. Okay. Now also, can we depend for designs on steel or
Oh, obviously,
we?
obviously, but the record is check on hand calculation with that software is that minimum 1-2% varies. That's okay, but varies is much. Then I think loading or anything else in conditions is different for them. So otherwise, it's come similar, same.
Okay, sir. Okay, sir.
But hand
Okay, sir.
calculation, one hand calculation is required for first answer.
Mhm. Okay, sir. Thank you for your highly informative session, sir. I think on behalf of Vivekananda Institute of Technology, I wholeheartedly thank you for giving such a wonderful information. I thank the participants also for being a part of this webinar. Sorry, we could not able to
Actually,
take up
long time,
your
long time.
question and answer session because of this was a long session. Otherwise, we could have definitely taken the question and
That's
answer session.
sent by mail, sir. I give you, sir. This is,
If we have any questions, we will just post it to our sir, Sajal Kumar sir, and I will after getting the answer, I will just put it in the group itself.
yes, sir.
Yeah. Thank you so much, sir. We will end this session.
Okay. Thank you, sir.
Thank you, sir.